All right, Mr. Ahmed here for 7.3. Goal for today is to look at proving that a quadrilateral is a parallelogram. So yesterday we discussed the properties that parallelograms have, and if we see a quadrilateral, which is a four-sided figure, that has those characteristics, we can assume that it is a parallelogram. So if both pairs of opposite sides of a quadrilateral are congruent, then that quadrilateral is a parallelogram. So in this case, both pairs of opposite sides are congruent. If that happens, then we could state that it is a parallelogram. So we would know more information. So once we know that it's a parallelogram, we also would know that its opposite angles are congruent. Its consecutive interior angles are congruent, are supplementary. So we don't necessarily know all of those features, but if we know both pairs of opposite sides are congruent, we know it's a parallelogram. In a similar manner, if both pairs of opposite angles are congruent, then we can state that it is a parallelogram as well. So we would know the opposite sides are congruent, we would know the consecutive interior angles are supplementary, and we would also know that the diagonals bisect each other. So if opposite angles congruent, then it's a parallelogram. So a couple examples here. Which theorem could I use to state that the figure is a parallelogram? Well, since the opposite angles are congruent, both pairs, I could use the opposite angles converse. I'm pretty sure in the textbook it might say parallelogram opposite angles converse, but it should be pretty straightforward for the most part for us to know that that's what we're going to use. So I guess I better say parallelogram too. So parallelogram, opposite angles converse. All right, opposite angles congruent, it's a parallelogram. All right, which theorem could I use to state that the figure is a parallelogram? Well, in this diagram, both pairs of opposite sides are congruent. So I could use the parallelogram, opposite sides converse. Okay, since both pairs of opposite sides are congruent, we know it's a parallelogram. All right, a couple more ways we can show that the figure is a parallelogram. If one pair of opposite sides is both congruent and parallel, if that happens, then I can state that it is a parallelogram. And once we know it's a parallelogram, we know more information. I would know these sides are congruent. I would know the opposite angles are congruent. I would also know the diagonals bisect each other. And our last one, if both pairs of diagonals bisect each other, then the figure is a parallelogram. So we took all the properties from yesterday and just looked at the converse, okay? So if these diagonals bisect each other, then we know it's a parallelogram. So then I would know the opposite sides are congruent, opposite angles congruent, etc. So which theorem could I use to show that the figure is a parallelogram? Well, I could state, let's see here, I got 4, 4, so the diagonals bisect each other, so we would use the parallelogram. Diagonals converse. Okay. And finally, which theorem could I use to state that the figure is a parallelogram? Well, I see one pair of opposite sides is both congruent and parallel, so I would use the parallelogram. Opposite sides congruent and parallel theorem. Okay. And the other kind of style of homework question that you're going to see is you're just going to see some questions where you'll see a figure drawn, something like this, and you'll see X, you'll see 8, you'll see Y, you'll see 10. And it'll say what value of X and Y would make the figure a parallelogram. Well, for this to be a parallelogram, Y would have to equal 10 and X would have to equal 8, because then the opposite sides would both be congruent. So that's all we got for today. So realistically, not a lot of new information. We just looked at the opposite theorems from the day before. The only thing that was different was the opposite sides parallel and congruent theorem, where we had to look and see if one pair of opposite sides was congruent and parallel. Then I would know it's a parallelogram. All right, have a good one.